Alright, so we want to look a little bit more at the Weierstrass substitution for trigonometric functions. This deals with any integral where we have some trigonometric function with respect to a variable, and we could have other things in there. Then we can pretty much rewrite everything in terms of polynomials in terms of t. So that was really helpful for us. So we're going to look at two examples, and we will see how that goes. There's also one more thing that I forgot to mention, which was that the cosine substitution is actually 1 minus t squared over 1 plus t squared. I think I may have made a mistake for that, but just let me clarify that right now before we dive into some examples. All right, so let's look. So here I want us to try integrating 1 over 1 plus cosine of 2x dx. Now this is something that looks pretty scary, right? We've never seen something like this before. We've never seen these trig functions thrown so casually into these types of functions here. We've dealt with trig functions with powers, but we've never dealt with these sort of weird functions where cosine waves are just kind of in there. They're just incorporated weirdly. So in order to do this, we are going to make a Weierstrass substitution. So we are going to let t equal tangent of x. Notice how we have cosine of 2x in here. So instead of letting t equal tangent of x over 2, we're going to let it equal tangent of x. So that means that x is going to equal the tangent inverse of t, and then cosine of 2x is going to equal 1 minus t squared over 1 plus t squared. And dx is going to be equal to 1 over 1 plus t squared dt. Okay, so let's have a look at where this takes us. So we're going to replace everything where we see an x with a t. So notice how I'm finding what x equals, I'm finding what cosine of 2x equals, and I'm finding what dx equals, because I'm replacing everything with an x in there with a t. So this gives us the integral of 1 over 1 plus cosine of 2x dx is equal to the integral of 1 over 1 plus t squared over 1 plus 1 minus t squared over 1 plus t squared dt. Now this looks pretty messy, so I'm going to omit a few algebraic steps, but you need to combine fractions and then you need to divide by fractions. Once you get this, you're going to get something that simplifies really nicely. You get the integral of 1 over 1 plus t squared plus 1 minus t squared dt. Those t squared terms are going to cancel out just like that. You're going to be left with the integral of dt over 2. I don't know why there's an extra dt there, but we only need one dt. So we have the integral of dt over 2, which gives us 1/2 t, and that's equal to 1/2 tangent of x plus c. And that's our final answer for this Weierstrass substitution. So as you can see, it looks pretty good right now. And yeah, these make it very easy for us. Let's try another one. So let's try the integral of 1 over 1 plus sine x dx. So now because we just have 1x, then we are going to need to do the tangent of x over 2 substitution. So we let t equal tangent of x over 2, then we can find sine x and dx. So sine x, this is just a normal Weierstrass substitution that we remember from last video. We have 2t over 1 plus t squared, and then dx is equal to 2 over 1 plus t squared dt. So now we are able to perform our Weierstrass substitution, replace everything in terms of t. Let's try it. So this gives us the integral of 1 over 1 plus sine x dx. That's equal to the integral of 2 over 1 plus t squared all over 1 plus 2 plus, or 2t over 1 plus t squared dt. And once we simplify all of this, we get a quadratic term on the bottom. So we get the integral of 2 over t squared plus 2t plus 1 dt. And now we can, this might look a little scary, but we could just factor the denominator. That gives us something that's really nice. We make a mental U substitution, and then we get a nice term here. We get the integral of 2 over t squared plus, or t plus 1 squared dt. We do the mental U sub, then we get negative 2 over t plus 1. And as you can see, this reverse simplifies to negative 2 over tangent of x over 2 plus 1 plus c. Okay, well, that's all I've got for Weierstrass substitution. I'm sure in a more advanced calculus series we'd cover Weierstrass a little bit more, but that was a nice little introduction, and I would encourage you to derive the integrals of secant and cosecant with these substitution methods. So in the next video, we're going to be moving on to one of our last integration techniques, or one of our last analytic techniques. We'll be doing some numerical approaches later as well, but we're going to be looking at integrals of rational functions and using partial fractions. Now, partial fractions, if you are a high school student who may have learned this in pre-calculus, this might be getting you all scared because it is some tedious algebra work. So we will be looking at that and just say this rational function, we're a little bit less friendly and it factored into something that wasn't just a nice term here. Well, yeah, you'll see what happens. It gets pretty ugly.